All right, so remember that derivatives are instantaneous rates of change, right? They're geometrically, they're slopes of tangents. Okay, and in science, many quantities change over time. We say they change with respect to time because they are functions of time. So I want to just investigate 3 examples just to contextualize this idea a little bit. So if S of t is the position of a cyclist t hours after the start of the race, then what does S prime of t mean? S prime of t is the rate at which S position changes with respect to time, or you could say over time. I'll use with respect to time. So what do we mean by S prime of 2 is 18? S prime of 2 is 18. Remember, S prime of 2 is the slope of the tangent line to the curve S when t is 2. So if we want to just give ourselves a little sketch, sorry I can't draw a straight line. Here are my time units, and we did time in hours. And here are my S units. We could do this, ST. My S units are in miles. Maybe my position function looks something like this. At time t equals 2 hours, so 2 hours after the start of the race, 2 hours after the start of the race, the derivative is 18, meaning the slope of the tangent line to the position curve, this guy's slope, is 18. Right? Slope is rise over run. It is miles units over hours units. Maybe we even want to write 18 as 18 over 1 and see that we've got our time units here. Hours. Oops, Lindsay's dyslexic. Miles per hour. S units, which are miles in this case, and T units, which are hours in this case. So when I say S prime of 2 is 18, I'm saying 2 hours after the start of the race, the cyclist is traveling 18 miles per hour. At that instant, if you took a picture of him 2 hours into the race, what's his velocity? It's 18 miles per hour, his speed with a direction. So let's write that. 2 hours after the start of the race, the cyclist is traveling 18 miles per hour, per 1 hour, I think I'll even say. We have a special name for the rate at which position changes with respect to time, and that's velocity. Velocity is 18 miles per hour. Excellent. Let's do one more. Okay, so in this example, P is the population of the bacteria, T minutes after cultivation. Then what does P prime of T mean? P prime of T is the rate at which what changes? P. P of T, which in this case is population, changes over time. To time with respect to T. So P prime of 15 being 500 means that when T is 15, so 15 minutes after cultivation, my bacteria population is changing at a rate of 500 bacteria per 500 is 500 over 1 per 1 minute. Let's draw a picture. Here's my population of bacteria. Here's my time in minutes after cultivation. I'm just going to write minutes. Say the population like explodes and then it's not increasing. It's still increasing, but just at a slower rate. 2 minutes after cultivation, P prime, I'm sorry, I'm thinking 2 minutes from before. It's 15. I'm going to change that to a little 15. 15 minutes after cultivation, the slope of the tangent line to the P curve is 500 over 1. Pretty steep here. My picture isn't totally to scale, but my slope right here is 500 if you want 500 over 1. 500 over 1, those are population units over time units over minutes. P units, so number of bacteria over my T units, which in this case is minutes. So 15 minutes after cultivation, what's true? My population's rate of change is 500 over 1. And I think I want to say that that's positive 500 over 1. So what does that mean? My population is, this is positive, my population is increasing at a rate of 500 bacteria for every 1 minute. The bacteria population, I'm going to write just pop for population, is increasing, right? Because this is positive. At a rate of 500 bacteria every 1 minute. Okay. And because I emphasized that, let's just go back and look at the velocity again. I didn't mention this being positive, but that means we are moving in the positive direction, which would be, in other words, my cyclist isn't double backing on himself and going in the opposite direction, right? It's a race he keeps or she keeps on that path. So he is increasing or she is increasing the distance from where they started at a rate of 18 miles for every 1 hour. All right? Let's do our final example. So here, V of T is the volume of Lake Cambria in Zimbabwe, and it's measured in cubic kilometers, T days after January 1st. Then what does V prime of T mean? V prime is the rate at which what changes? V. V, which in this case is the volume of this lake, changes over time. I'm going to write with respect to time. So V prime of 20 being negative 12 means 20 days after January 1st, the lake is changing at a rate of minus 12, or if you want, minus 12 over 1. These are volume units, which is our kilometers cubed, over our T units, which is days after January 1st. T units, days per day. Let's get a little sketch. Here's my time in days after January 1st. I'm just going to write days. And here's my volume axis, which is in kilometers cubed. Say the pop on January 1st, the volume is way up here, and then it's starting to go down, and then coming back up. 20 days after January 1st, the slope of the tangent line to the V function is minus 12 over 1. It's down 12 to the right 1. The slope is minus 12 over 1. Now, because it's negative, let's get a new color here. Because it's negative, that means my volume is decreasing. And it's decreasing at a rate of 12 cubic kilometers every 1 day. 20 days after January 1st, the volume of the lake is decreasing at a rate of 12 cubic kilometers every 1 day. I'm just going to write per 1 day. All right?